Okay, we're going to talk about equations of circles today and how to graph a circle. If you guys would like this to be brighter, if someone wants to turn off the second switch, we can. It's up to you. Thank you. The general equation of a circle, x minus h quantity squared plus y minus k quantity squared equals r squared. A circle with its center at the origin is simpler. X squared plus y squared equals r squared. That would be the simplest equation for a circle. And that's where the center's at the origin. So with what I just said, since you're pretty intelligent and maybe you have some insight into what this is going to do. What's the h and the k then if I just said this? This is one with a center at the origin. This one has a center that's not the origin, okay? So it's shifted. All right, so explain how you find the center and the radius. I'm going to say very simply that the center is hk, the point h comma k, and the radius is r. So what do? Oops, oh no, I wrote or. The radius is r, so you take the square root of r squared to get r. Ready? So we're going to write the equation of a circle with a center at the origin and a radius of 5. So since its center is at the origin, all we have to do is do x squared plus y squared equals 5 squared. And as we should simplify the 5 squared to 25. That's how the equation would be in the book or on a standardized test. Now, if I want to write the equation of a circle in number 3, if it's shifted 4 units to the right and down 2, then I got to do something different. That would put its center shifted 4 to the right would be at 4, down would be negative. So its center is at 4, negative 2. This is your h, and this is your k. I am at the top of your paper on the notes page, correct? Okay. I just didn't remember the shifting question coming up this early on. But if you think about it, all it's done is slide the circle, and the center moved. It said 4 to the right and down 2. So now we would put into the format, whereas x might, you don't have to rewrite this because you have it at the top of your paper. This is where we're going to plug in the h value and the k value and the radius. So we're going to put in a 4 for the h, so it's going to say x minus 4 quantity squared plus, and we're going to put in k. What's it going to say if we do y minus negative 2? Yeah, so if you can jump right to plus 2, do it. And then the radius didn't change, so it's still going to be equal to 25. But I would expect that you fixed this and simplified it down to, and if you went straight to this, that's absolutely fine. This would be your final answer. Anybody still need this? All right. So now we're going to identify the center and radius of each, then we're going to sketch the graph. So center for this one is 0, 0. R squared equals 9. So we take the square root of both sides and get the square root of 9, which is 3. Okay. Now we're going to graph it. So in order to graph this, we need to plot the center, but I want you to realize that the center is not actually part of the circle at all, because the circle is just this part. My head's not included, even if it is at the center. Okay, so I made my arms into a big circle. Somebody can't see that when they're listening. So we have to plot, well, the 0, 0 is simply the centermost location of which the radius, everything located on the circle is that many units from that center point. So we got to go 3 to the right, 3 to the left, 3 up, and 3 down. You cannot go in any other direction, and you're just going to be sketching it now because you can't count 3 on here. If you went, you can't count diagonals, otherwise you'd make a box. And this is supposed to be a circle. So connect. Yours isn't, mine's looking ugly. Oh well, if it comes out like that, that's the way it comes out. I'll know what you meant. I just don't want to see any diamonds. Oh, that was a ginormous eraser. Oops. I'll just try to do a little bit better. Okay, that wasn't much, but. All right, so some of yours will look like ovals. Some of them will be better. I actually do a better circle on the board than I do on here. Okay, this one, center is at, it's supposed to say x minus h. So what's the h? It says minus 4, so h is a 4. And then it's supposed to say y minus k, and it doesn't say minus 3. It says plus 3. So what must k have been? It's always the opposite of what you see here. Okay, so that'd be negative 3. And then r squared is equal to 4, so we take the square root of 4 and we get 2 for the radius. So now we go to 4, negative 3. Then we go 2 to the right, 2 to the left, 2 up and 2 down. Sounds like an exercise. Make a little circle. I did much better on that circle. Oh well. Okay, so now we've graphed your first circles. And we're going to continue graphing, I guess, some more because there's 7 and 8 here. Center of this circle is at negative 1, 3. R squared is 9, so the radius is the square root of 9, or 3. We go to negative 1, 3. And then start counting vertically, horizontally. 3 away from there. Okay. Number 8. Uh-oh, what happened? We have a center at negative 3, and then there's no k, so we write 0. R squared is 16, so r is the square root of 16, which is 4. Go to negative 3, 0, which is on the x-axis. And 1, 2, 3, 4 to the right, 4 to the left, etc. I should really do bad on this one. This is a bigger one. And sketch. There aren't too many people who can draw perfect circles freehand. Nope. I can do pretty good on the board, but these are, yeah, there's some artists that, forgot who it was. Oh, I have to look it up. Find out who made perfect circles. Okay, so what we got to do is locate the center now. Looks like that would be the bullseye on that one. Count, oh, sorry, you need to flip, right? Bless you. 2, actually I looked up here to check out the number line and make sure I could tell how these were spaced. Is yours got the lines in between too? It is? Okay, yeah, I don't like that paper. But anyway, you can see where halves are really nice on this if you needed to. So 1, 2 is the radius. So you're just counting over from the center. And now you say, okay, where is that center? Well, it's located at negative 2, negative 4. And I found the radius to be 2 by counting. And now I just pop that into my little format. Reminder, it's, oops, x minus h quantity squared plus, I have delayed reaction on my pen, just a moment, plus y minus h, excuse me, can't do h twice, k quantity squared equals r squared. All right, so I'm popping these in, so it's going to be x plus 2 squared plus y plus 4 quantity squared equals 2 to the second, which would be 4. Where's the center on the next one? Ooh, I think it's right there, right? I don't know. I eyeball it. You could find like the highest point, and if that doesn't work for you, because not everybody sees that easy. If you find the highest point on the circle and cut it in half, and then find the widest points, the furthest to the left and right, you can do that and find the center. So here, if you see the very topmost point here, you can come down. Feet go to the sides. The domain of this thing would be -3 to 3. The range would be, what is the range? -2 to 4. But there's the center. So that was a way to locate it. Next, we'll write down the location of the center. It is at 0, 1. And the radius, anybody, 1, 2, 3? Time to write this, since there's no h, if you plug in a 0 here, you're going to have x squared plus y minus 1 quantity squared equals 3 squared. And of course, that would be 9. And no, you do not need to FOIL this out. Remember what that means? Y minus 1 times y minus 1 is y squared minus 2y plus 1. Never mind. We'll talk about foiling and unfoiling very soon. Factoring is coming. Not yet though. All right, so we got center and a radius of 8, center 0, 0, so that's a simple kind. X squared plus y squared equals 8 squared. And of course you would write 64. So far so good, I hope. And then this one, maybe I need to show one of these where I actually plug it in. It says x minus h, which would be minus -9. In case anybody's not getting this, I'm going to do it a more basic way real quick. And y minus -12 equals 2 squared. So that's as if I plugged them in straight into that format. Then I would simplify and have y plus 9 quantity squared, sorry, x plus 9 quantity squared plus y plus 12 quantity squared equals 4. Okay, write these two. Oh, no, write that one. I need to help with that one. Got a new kind coming up here. What? Wait a minute. I know how to start that part, but how am I going to find the radius? You don't have to draw this, but this is saying that's at 0, 0. The center. And then a point on the circle is at 8, -15. So say 8, I don't know, something like that. I need this. Say that out loud, Brooke. Distance formula. Yep. Okay, now, just one, you don't need to write anything right now. Except if you'd like to write down the distance formula, I would do that. Distance is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Did anybody ever tell you that x2 minus x1 stands for the change in x? You don't have to write this down. y2 minus y1 stands for the change in y. You ever see it like that? Have you ever seen c? Don't write this. I'm trying to connect some dots for you, put some things together. C squared is equal to a squared plus b squared. Ever heard of that? It's a Pythagorean theorem. The length of this is called the hypotenuse. We're trying to find one right now. Sorta. Okay, this is the change in the x. This is the change in the y. All right, what if you solve for c? Does that look anything like this? A lot. And then there's this equation we just wrote. Do these look anything related at all? You know, there's a lot of similarities. Do you see what I'm getting at? That's all I'm trying to get at, is that there's a lot of connections there. So it's not that hard to memorize. Okay, so I'll just go backwards a second, and let's talk about the distance formula. So square root of, we just said x2 minus x1 quantity squared. I shouldn't have erased that, and I did. All right, now, what's a change in from 0 to 8? Okay, so the radius is the square root of, the change in the x's is 8. 8 squared plus, what's the change or the distance from 0 to negative 15? Okay, do you need it to be negative? What are you going to do to it? If you had a negative, you're still going to square it. So you don't have to worry about signs when you do the distance formula. You just need how far apart they are. All right, I could follow the formula, but this makes it easier. Okay, so 0 minus negative 15. Okay, let's just go with that. 0 minus 8. But then I'd get a negative, and then you guys might type it wrong. And so I'm just saying, how far apart are the numbers? And I'm going to go for it now. All right, so oopsie, r equals the square root of 64 plus 225, which is going to be 289. And the square root of 289 is 17. It's a perfect square. So actually, though, didn't I already, if I got a square 17, if the radius is the square root of 289 and you square it, wouldn't you get 289? Something. Okay, so sometimes if you get a square root for an answer for your radius, you're just going to square it anyway, so the radical would drop. Let's check out some more. Now I got a center at negative 10, 14, and a point on the circle, negative 8, 11. Well, we've already talked about how to do the beginning part. So it's going to be my h and my k. It's negative 10, so I'm going to do x minus negative 10 quantity squared plus y minus 14 quantity squared equals, and now I got to figure out that radius. So I'm going to do my distance formula up here. The radius will equal the square root of. How far is it from negative 10 to negative 8? Think about a number line. Not everybody's good at that. It is 2. So you could just do 2 squared plus 3 squared. These are 3 apart. Here, or we can do the formula. Negative 8 is your y2 minus your x. This would be your x2. This is your x1. Minus negative 10 plus, I'll do the long way, 11 minus 14 squared. Okay, so that's going to give you r equals negative 8 minus negative 10 would be negative 8 plus 10, which is 2. 2 squared plus 11 minus 14 is negative 3. If you're going to do this, though, you're going to have to be careful about squaring things on your calculator and making sure you're doing parentheses. So that's 4 plus 9. You should be getting the square root of 13. Now, once you got your radius, the square root of 13, and you plug it in here, you have to square it. Okay, so I'm going to go ahead and simplify everything now. This is going to be x plus 10 quantity squared plus y minus 14 quantity squared equals 13. Now, those aren't too bad. We got one more level of difficulty to go. This is not all that bad. And that will be if they don't give me the center. So we're going to describe first how to find the equation of a circle given the endpoints of the diameter. Okay, so here's the idea. You got a point A and a point B. Ooh, that doesn't look like it's going to hit the middle. So you have one point, x1, y1, and another point, x2, y2. You need to find the center, HK. And these represent a diameter. Somebody have an idea? Okay, so I've seen a few hands go up, and I have a couple of names, so I'm still for. Well, I know. God, and I'm trying to remember Hannah. I don't know why I should have that stuck in my head yet. So, say that again, sweetie. So, well, okay. To do what though? What would we be doing then? Finding. You're going to find what? Okay, we need to find the center, absolutely. But do you know? Like, this isn't on a number line where you can go like that, you know, and find the middle. Do you remember how to find the middle? What's it called? There you go. I heard it. Midpoint. Maybe that's what you're thinking. Okay, midpoint. Is that Nick? Okay, midpoint. Find the midpoint, and then some of you were saying it over here. Okay, that's one thing we do need to do. We got it. All right, so let's go ahead, and since we already talked about that concept, let's say to find the center. Use the midpoint formula. You remember what that is? Okay, Nathan, right? No, sugar, I did it again. Dan, no, Matt's on that. That's Dan. Got it. Perfect. Yep. That is the midpoint formula. It averages the x's and the y's. And then you find the midpoint. So that would be the center. Okay, what are we going to do, though, to find the radius, which is in our formula, Brooke? Okay, use the distance formula between, once you find the center. Okay, and I think that's a well way to do it. But what if you made a boo-boo on your center on accident? Then you're going to get your radius wrong also. So I usually tell a way to do it so that you didn't have to find the midpoint first, although it is a great way to do it. Most people are going to add and divide by 2 fine. Scott? Okay, so yes. So I don't mind. I think, Brooke, yours way is perfectly fine. But as I was suggesting, let's discuss what would we do if somebody did find the distance all the way across. Okay, so find the distance between the points, the endpoints, and then divide by 2. Okay, then then we would plug it in. Okay, plug in the values. All right, let's try one. So thank you for your input, people, class, for helping decide how we want to describe to do the problem. So literally last, when I did the second hour, we did the distance first. So that made no one say what you said, Brooke, because they hadn't found the midpoint yet. You know, haven't found the center yet. Okay, here we go. Use the information provided to write the standard form equation of each circle, and that's going to be x minus h quantity squared plus y minus k quantity squared equals r squared. All right, so this is what we're looking to do. We got diameter endpoints. What do we want to do first? Do you want to find the center first or the diameter or what? I don't care. Center first? All right. So let's this x1, y1, x2, y2, just to help anybody who's a little rusty on the formula to go ahead and see what I'm doing. 18 plus 2 would be my first step. And then divide that result by 2. Make sure you're not trying to type that in your calculator. 14 plus 2 divided by 2. Because you have to add before you divide. So that's 20 divided by 2, which is 10. This is 16 divided by 2, which is 8. There's my center, which gives me my h and my k. Okay, now I'm going to find, do you want to go from the center to one of the points, or do you want to do, so I don't mind, or you want to use the original points and find the diameter. Okay, you do that, and I'll do the other. No, I'm not, what was it? I meant it. You should get the same thing. It's fine. Aw. I could do it your way if you want. But I'm going to find D for the diameter. Just the heck of it. 18 minus 2. And see, I don't care if you go in the opposite order for your, let's do the easy way. We don't have to do x2 minus what? x1. We can do x1 minus x2. You're allowed to do that. 18 minus 2. And 14 minus 2. And then I get the square root of, let's see, 16 squared. These are big numbers. Plus 12 squared. Wait, that's 400, isn't it? 256 plus 144. Square root of 400, and that's 20. But that's the diameter. So the radius is half of that. It would be 10. Did you get 10 for your radius, Cameron? Good job. All right, here we go. Let's plug in the stuff. We got an H, we got a K, and we got an R. So we're ready to do it. X minus 10 quantity squared plus Y minus 8 quantity squared equals 10 squared, or let's just do it. What's 10 to the second? Yeah, 100. Did I go too fast? Haley, you okay? Because I went up there from there, and sorry, I took this and I went and put it in and took that one and popped it in. All right, I'll try to be neater. Endpoints of the diameter. Oh, this is a nice one because the origin is at, no wait, that's not the origin. That's the origin, but it's not the center. So I still got to figure out stuff. I got to find the midpoint. 0 plus negative 12 divided by 2 and 0 plus 10 divided by 2. And maybe you might have noticed that if one of the points is 0, 0, just cut the other one in half and call it a center. That would be negative 6, 10, 5. Okay, so I got my H and my K. And I'm just going to go ahead and find the diameter because I want to show you something. 0 minus negative 12, that would be 12 squared, plus 0 minus, I don't care if it's negative, so 10 squared. The distance between 0, 0 and negative 12, 10 is 12 and 10. And now square those numbers to finish it off the formula. All right, so I've got something weird. It's a square root of 244. And I'm supposed to cut that in half for the radius. But I don't want you to type it on your calculator. So I can review a little bit of radical stuff that you probably really loved. Oh, get ready, because it's coming. We'll be graphing them, we'll be simplifying radicals, and yes, you'll need to know it very well. Ready, set. X. H is a 6, negative 6, so we're going to write X, parentheses, X plus 6, quantity squared, plus Y minus 5, quantity squared. And now I got to square this. Okay, so all I wanted to remind you is how to square this. When you square a radical or a fraction, gosh, we got two things that we don't want to see over here. You've got fraction, one of those F words of math, and we're going to have, and we have a radical, which behaves badly. Okay, if you take this and square a square root, what happens to it? It goes away, right? So, it what? Goes poof? Okay. All right, poof, the radical part's gone. What happens when you, what did we not square yet? Got to square the 2 also. Okay, and that's 4. So now the final answer, this thing is actually 61. So Karen, you did it without, you found the center, right? And then you did the center to a point on the side. Did you do that on this one? The last one, okay. So this one, if you had done that, it would have made this problem easier. You would have got the square root of 61, and then we would have just squared the square root of 61. All right, couple more. Here's a new concept. So, translated right and down 3. Some kids would not look at this and be comfortable with what to do, whether they should add or subtract or whatever. So here's what I suggest. The center for this circle is 1, 1. It's telling us to translate it. So what a translation means, and we're going to talk about translating things all year long, we're going to be graphing so many different types of things, and then we're going to be shifting them and sliding them around. You're going to get really used to it. So if I shifted this thing 4 to the right, then that would be a X change or a horizontal change. So I could figure out the new center and where it is. The new center, because the radius isn't going to change. The circle didn't get stretched or anything, so it's just staying the same. So if I translated 4 to the right, that would add on 4 to the X component of the center of the original circle. So that would be 5 now. And then 3 down, up or down. Well, down means go down, so it's negative, not positive. So you'd subtract 3 from the 1, and that would give us negative 2. So now the new center is at 5, negative 2. This part did not change, the radius, so we're just going to change this equation up to say X minus 5 quantity squared plus Y plus 2 quantity squared equals 64. Okay. Any questions about what I just did? No? All right, then we'll try another one here. This center of this circle is at 10, 9. Radius doesn't matter. We're going to translate it left 1 and up 4. If we're going left 1, that'd be minus 1. If we're going to go up 4, we're going to add 4 to the Y part. So the new center is going to be at 9, 13. All right, fill it in. x minus 9 quantity squared plus y minus 13 quantity squared equals 25. Your homework is the next page that says practice on circles. Have a great evening.